Hi, I hope you can hear me. So, welcome to Randomania, which is the name of this channel, of course. And my name is Sir Shark. Enough about me, let's get into this video. It's going to be about calculus, and also I'm going to be discussing the Mr. Beast drama. So, if you don't know who Mr. Beast is, well, then you must be living under a rock, probably. Because yeah, he has like 300 million subscribers and stuff. And recently he's been in drama, surrounding a lot of things. His like lotteries, Amazon Prime show, some of his associates, particularly Ava Chris Tyson, he's been recently accused of being a pedophile. So yeah, that's pretty interesting. But you know what's more interesting? Discussing advanced integration. Now, if you don't know what integration is, let's start from the basics. Here's a line. It's not very straight. That's okay. Do you want to find the gradient of this line? We need something called rise over run. Yeah, so find the gradient of this line, you need to divide rise by run. You can think of rise as some value y and run as some value x. Because y is above x, so think about it, rise is vertical and run is horizontal. And rise is above run. Get it? And y is above, okay. So rise over run is equal to the gradient of this line. What does gradient mean? Well, another word for gradient is slope. And slope is basically the leaning of this line here. You can also represent it using an angle, say theta. And this is 90 degrees minus theta, because this is a right angle. So if we incline this line by 90 degrees minus theta, we get the the gradient of this line, which is also called the slope. Now, what does this have to do with calculus, you may be wondering? Well, to find the gradient of any line, which includes curves, like this smiley face, we need to find the gradient of a point. How do you do that? Well, we use something called tangents. A tangent is a line that touches a curve at exactly one point. Now, let's look at this line back here. Rise over run. Well, to calculate y, we need 2 points. This point and this point. And to calculate run, we also need 2 points, because we need both of the coordinates. Let's say the coordinate of this line is x2, y2. And this coordinate of this line is x1, y1. Where x1 is the horizontal position, x2 is also horizontal position of the second point, y1 is vertical position of the first point, and y2 is the vertical position of the second point. To calculate the gradient, we need to do y2 minus y1 over x2 minus x1. Yay, we found the gradient of a line. Cool. So, back to tangents. If we only have 1 point, how do we figure this out? Because let's just say this is like x0, y0. Well, then gradient would be y0 minus y0 over x0 minus x0. And that gives you 0 divided by 0. If you don't believe that this is indeterminate, you can ask Siri, what's 0 divided by 0? And she'll give you a great answer. Yeah, so I'm going to explain why this is not a real value. So how do you solve this then? Well, we use calculus. Wow, we're learning calculus already. Okay, so if you look back at this thing, right, this line, let's just say the equation of this line is some f of x, which gives an output, which is the rise, from the run, which is x. Okay, so what does this mean? To find the coordinate of this line, we take x1, f of x1. And the coordinate of this point is actually x2, f of x2, because we just use the function on the x coordinate. Okay, so let's go back to this. Let's say the equation of, actually let's go back to this one because it's easier. Let's say the equation of this curve is some f of x. And you'll want to find the gradient. So let's say this point is x, yeah, just say it's x0, y0 again. I'm not bothered to make a new coordinate. The y value, which is y0, is also equal to f of x0, because we defined f of x to be this equation of this curve. So define the gradient. Let's just say there are actually 2 points, one imaginary point. Let's just say that this point is x1, f of x1. But we want the difference between x1 and x1 and x0 to approach 0, because we're just measuring from one point, because the curve, right? It's not straight. Yeah, it's not straight. So we want x1 minus x0 to approach 0. Okay. Now what do we do? Okay. Well, you can still find the gradient of this is by using this formula applied to this formula. So using the f of x notation, we can find that the rise is in fact f of x1 minus f of x0 over x1 minus x0. Rise over run. But the problem is x1 minus x0 is 0. But instead of just saying that x1 minus x1 minus x0 is 0, because that would just make 0 over 0 again, let's just pretend it's just approaching 0, right? As 2 imaginary points get closer and closer to this point. We call this limits. Yeah, limits. So let's say x1 minus x0 is some number n. So n is approaching 0. We call this lim of n approaching 0. Yeah, okay. That is anticlimactic. Let's just put this back into here, and we get limit of n approaches 0. Denominator is also equal to n, and the numerator we can just keep this as f of x minus 1 minus f of x0. And this is a formula for the gradient of this curve, which is also called the derivative. Yay, we've learned calculus already. Okay, if you don't know what a function is, we probably shouldn't be watching this video. Although maybe you're watching this video because you want to learn about Mr. Beast. But Mr. Beast is a DLC, you see, so we need to get to integration first before we deal with him. Now, back to derivatives. Lim of n approaches 0 of f of x minus 1 minus f of x of 0 over n gives us the gradient of the curve. But we can't really do anything with this if we're just taking like a random function f of x. So let's just say f of x is equal to some x squared. If you don't know what x squared means, it just means x times x. And if you don't know what multiplication is, it means you add x to each other, x times. If you don't know what addition is, let's see, what is addition? The action or process of adding something to something else. Okay. Now, let's go back to this. So now we know what x squared is, which is the function. We can go back to here and take x squared as the function for this. So we just square x. Yep. You just do this, right? F of x1 is equal to x1 squared. F of x0 is equal to x0 squared. And this is over n. Now let's substitute n as x minus 1, x1 minus x0 again. Okay. Now we use something called the the difference of squares formula. We can factor this into x1 minus x0 times x1 plus x0. Yay. If you want to know how this works, okay, you just multiply 2 at a time. Yeah. So x1 squared plus x0 x1 minus x0 x1 minus x0 squared. It just cancels out the x0 x1 terms, which gives us x1 squared minus x0 squared. And we divide this by x1 minus x0. we ignore the fact that x1 minus x0 is equal to 0. We just say it's approaching 0, right? And it's approaching 0. So let's divide this by x1 minus x0 on both sides. We get lim n of 0 of x1 plus x0 is the expression. And then we turn lim, we turn n into equal, n is equal to x1 minus x0, and we say that n is 0 now, so x1 is equal to x0, so turn this into limit x1 is equal to x0. It's not really a limit anymore, so that's fine because we got rid of the denominator, so this works. This gives us 2x1. It's actually 2x0 since the initial point is x0, y0. And we got the gradient. Yay. Okay, yeah, yay. Okay, so this is the gradient of the curve y is equal to x squared at point x0, y0. Well, yeah, and y0 is also equal to x0 squared since we just substitute from this. So that's basically first principles differentiation. This is the formula for differentiating anything. Now, what about integration? Well, actually, integration is just opposite of this. So instead of taking the limit of some random point on a curve, we do the opposite. We find the original thing if this was a limit initially. Okay, if that made no sense, then I agree. Let me think. Okay, back to y is equal to x squared. So let's say we want to integrate this. So to integrate this, we write this fancy s that's called the integrand, and they write something called d of dx. Don't need to know what this means yet. We're just worrying about x squared and how to integrate this. So you need to work backwards from x squared. What differentiates to give x squared? Oh, actually, you know what? What would be easier? We're saying y is equal to 2x, then saying this is 2x dx. Because from here, we have found that for any y is equal to x squared, differentiating this gives 2 times the x value of the point on the curve. So we can just basically say that x squared derivative, which is given by this squiggly prime line, it's called the prime. Yeah, it's like prime energy. We'll get into that later. The prime of x squared is equal to 2x. Cool. So if we integrate 2 of x, we just reverse this. So this becomes x squared again. You add dx, you have to always add dx, or not, depends. Which turns into x squared. But if you think about it, oh, actually, I didn't even show this. No. If you think about it, if you have any constant, a constant is just like any normal number, like 1, 0, 1, 2, 2, like anywhere. Yeah. If you take any constant, put it into this function, let's say like y is equal to x squared plus 1, well then you're going to see that this cancels out because, yeah, when you differentiate things, the constant disappears. It turns into 0. So for any constant you add to this, let's say plus c, where c just means constant. If you don't differentiate it, it just goes 2x anyways. So when you're walking backwards, you have to keep this in mind. So we say x squared plus c, because if you differentiate this goes 2x anyways. That is how you integrate. And if you didn't understand anything I just said, well, let's go back to Mr. Beast. So Mr. Beast, very popular YouTuber, probably the most well-known YouTuber in the world right now. He still does philanthropy events. He also does like, wait, let's see, Mr. Beast show, yeah, no, not these. Okay, these are different channels. TV series 2012. Philanthropist and okay, yes, Kris Tyson. Yeah, he changed his name to Kris because it's female. Well, technically his name is Ava. Oh, her name. I don't really care. Yeah, so basically, she is a pedophile. Yeah. Basically, she had a picture of an underage girl on one of Mr. Beast videos, and Mr. Beast was fine with that. And then Mr. Beast himself got into drama from this. Got accused of a bunch of accusations by one of his former ex-employees called Dogpack404. And then Dogpack404 got recently exposed by Soggy Cereal, which, yeah. So it's very complicated, and most of the channels covering it just making money off this slop, basically, because we don't even know what's happening right now. Like, is this guy guilty or not? He's probably guilty of at least something. Like, he's not the perfect guy that people thought he was for some reason. But obviously, I'm not going to like diss Mr. Beast. He's kind of successful. I mean, he's extremely successful. So I'm going to actually acknowledge his sigmality and admit that he has an upper hand to most people. Like, even if he gets cancelled, it's not going to affect him at all. Like, cancellation, he's never going to go irrelevant unless for a very long time. Yeah, so back to integration. Mr. Beast here is a variable. Oh yeah, I didn't even tell you what a variable is. Well, I hope you know what a variable is. So it's basically not a constant like this. No, it's like this. Letters, yes. You're going to see letters a lot in advanced maths, or even maths in general, like high school. You're just going to see lots of these variables. And variables, as suggested by the name, the values can change a lot. Yeah. So Mr. Beast here is variable because anything can be a variable, really. Even I'm a variable. We are all made of variables. Everyone is a variable. Where's it going? Oh yeah. So if you integrate Mr. Beast here, we get half Mr. Beast squared plus c. We always have plus c here because, yeah, constants. So basically another way to say this is integral of x dx is equal to half x squared plus c. And you can easily show this because derivative of x squared is 2x, right? And something to keep in mind is that any constant being times by the x squared, or like any function x, that goes to the differentiated part as well. We call this a coefficient. It's a constant. It's a constant part that's being multiplied by the variable. Also, technically speaking, like x y squared is equal to x times y squared. So x is a coefficient of y squared in this case, but it depends on what you're differentiating in respect to. What does this mean? Well, remember d of x. Dex, I'm gonna call it dex for short. Let's say dex. Oh my god, this is very messy. Okay, dex means that we're differentiating the expression in terms of x. So differentiating x in terms of x dx, this is equal to 1. Because if you think about it, a graph that has equation y is equal to x has gradient 1. Because you can have 0, 0, that's y is equal to x, 0, 0, and 1, 1, that's also y is equal to x. And then 1 minus 0 over 1 minus 0 is just 1. So going back to here, the gradient of x is equal to 1, derivative is equal to 1. So taking the gradient of any point of a curve always gives you its derivative. That's the basic meaning of derivative. Now, if you think about the opposite of derivative, which is, of course, the integral, it actually gives you the area of the curve, kind of. So this here is what we call an indefinite integral. Indefinite means that it has no bounds. So this doesn't really mean anything, like x d of x. X is a variable, so that could mean anything. We don't know where to differentiate it under, integrate it under. Like at a gradient, we know to differentiate under some point x of 0. We can find the gradient of a point there. But with an indefinite integral, we have no idea what we're actually integrating. We don't know what this means. So let's just say we take something new called a definite integral, which has bounds, say a and b. And we take these bounds a of b of f of x, dx, because we're differentiating in terms of x. And a and b are constants, where a is above or equal to b. A is always, well, it's not always, but if it's the other way around, a is less than b, then you just flip the sign around to get negative integral of b of a. And you'll see why this is true later when you're talking about the practical applications of integration. I mean, there's also practical applications of differentiation, but not as much because it's more of a basic of a topic, and you can realistically find the gradient of anything, like even a curve. Just take a ruler, rule out points roughly, like put it against the curve, and then you can just find the gradient from there. But this is a more accurate representation of how to find a gradient for any curve, as long as you know the function. There's some curves obviously that don't have a function. Like this is not. It's not a function. It's just a scribble. How do you find the gradient of this? Well, you have to use a ruler, right? So, yeah. In practicality, you should just use like rulers or something. If you're working for NASA or something, then like, I guess you could use differentiation more. Or being an engineer at NASA. I don't know what I'm saying. Okay. Integral of a over b. What does this mean? Well, it means at some point on the curve, f of x, this is y is equal to f of x, because y is equal to the thing, the output. Let's just say this is point B, this is point A. B is less than A, and B is a point, a x point, a horizontal point, which has a vertical amplitude of f of B, and this has a vertical amplitude of f of A. We're going to find the area here. And to this, we find this using integration. I'll explain why this gives area in the future video. Basically, you just have to take my word for this because I'm Sigma, and you should believe in my aura. Yeah, so b f of b, a f of a. Find the area of this, we use integration. So we turn this integrand sign, fancy s, which means sum, by the way, into square brackets. And then we take a, b here, and this is just the integral of f of x, right? And then we ignore the c, because if you think about it, when you're minusing two things, right? Integral of f of x plus c minus integral of like g of x plus c, well, the c is going to cancel out because it's the same c, right? If it's from the same function, initial function, then the c should also be same. So just cancel out, right? Plus 0. Okay. Oh yeah, I forgot to tell you, the a and b is for minusing each other. So we substitute a into f of x, integral of f of x, and then b into integral of f of x. By the way, if you don't know who invented this, it's Leibniz and Newton. Yes. We don't know who invented it first. Newton said he invented it first, Leibniz said he invented it first. Yap. Like, what is this, bro? Oh my god. Okay, then you discover this. This is like way after them. Anyways, yeah, back to this. Integral of f of a minus integral of f of b. And this gives you the area under the curve. Actually, no. Yeah, an area under the curve. Sorry, I didn't mean over. The reason why it's under is because you measure from the x-axis of a Cartesian plane. It's like this, b, a, this is the area, squiggly. Yeah. If you don't know what a Cartesian plane is, then okay, Cartesian plane is two lines. One is right angle to another. This is y, this is x, because y is vertical, x is horizontal. The center is 0, which is why it's using coordinates, and you just move like here. Like, so this is length a, and this is a0. You add a to this. This is like length b. This is b 0b. You add b to this y coordinate, a to this x coordinate. Okay, that's basically what you need to know for that. And yeah, so this gives you the area under a curve. Now, what is the application to this in terms of Mr. Beast? Well, Mr. Beast. Let me just find a better picture of Mr. Beast. No, wait, yeah. Let's see images. Yeah, that's the better picture of him. Okay, let's take Mr. Beast here. So let's say Mr. Beast wants to give away $100,000 to 10 homeless people on the streets. Now, 10 homeless people, right? That's 10 people. Let's say this is 10x. X represents one homeless person, and we have $100,000 for each of them. Let's say $100,000. $1 is equal to y. $100,000 into 10x. Now, if you take, okay, I want to clarify that this is for the total of 10x people. So the amount of money given to each person is defined as 10,000, 100,000 y divided by 10x, which is equal to 10,000 y over x. Now, what does y over x mean? Well, let's just say the y is equal to f of x, where f of x is some function. Wait, okay, let's just say that f of x is equal to the function of money over people. Now, Mr. Beast obviously likes his money more than people, just like Logan Paul likes his cheese drippy, but we're going to ignore that for now. So y is equal to f of x. This is equal to 10,000 f of x over x. It's also equal to 10,000 f of x inverse x. Okay, what does this mean? Well, let's say we're going to integrate this in terms of x. So this is how you write it. This is indefinite, by the way. We're going to find the area of anything. To integrate this, okay, need to clarify something. I just realized this is going to be difficult. Okay, so let's introduce some things. First of all, integral of 1 over x is equal to natural log of x. If you don't know what natural log is, it basically means the log base of e of x. If you don't know what e is, let's say that e is equal to 2.71 something, blah, blah, blah. And log means the inverse of exponentiation. Like if you know x squared is equal to x raised to the power of 2, then log x of x to the power of 2 is equal to 2, because x to the power of 2 gives us x squared. And e is some special number, it's like 2.71 something. Yep, that's what we need to know. And integral of 1 of x is equal to this natural log of x plus c. You can figure out why this is in some time by yourself. Yeah. And when we are okay, Mr. Beast formula again. I can't do this. Okay. I guess this is over because we learned how to integrate Mr. Beast. But we did that a while ago. Anyways, Mr. Beast squared is equal to Mr. Beast times, okay, if you take the derivative of this, it's 2 times Mr. Beast times Mr. Beast prime. If we take this in respect to this picture, yeah, in respect to Mr. Beast. Yeah, so integrating Mr. Beast squared times Mr. Beast is also equal to 2 times Mr. Beast times Mr. Beast differentiated. And Mr. Beast differentiated is equal to Mr. Beast differentiated in terms of Mr. Beast. These are two different Mr. Beasts, by the way. If you want to know why, there's some good law. Oops. Good law of Mr. Beast. Yeah, Squid Game Mr. Beast. Two different Mr. Beasts. This is different Mr. Beast, obviously. If you couldn't tell that, you're probably blind. I'm not sure how you're watching this video, but hi to the blind people out there. Yeah, differentiating this is 2 times Mr. Beast times Mr. Beast prime. That's what you need to know. If you want to know why, you can find out later, somehow. If you learned something from this video, that's cool. Good to know. Bye.